So we are going to graph polynomial functions, and we're going to be kind of limited on some of the stuff that we're going to do. If you have calculus, you're more than welcome to do the actual max division points. But for the rest of us mere mortals, we don't know what it is. We don't know derivatives yet, so we're not going to do them. So we're going to just kind of do a limited one, but that's not a big deal because it's going to be pretty detailed. So you need to identify the degree and the type of the polynomial function. So you're looking at, you're graphing a cubic, a quintic, a quartic, a quadratic, a linear. Identify the sign of the leading coefficient. Sign of the leading coefficient because you need to know about the end behavior. Right? You need to know this stuff. We all know that. Identify the x-intercepts or the zeros of the function. Okay. So that's going to be the factoring part of it. That's going to be the synthetic division part of it. You may have to do synthetic division more than once in order to get the factors. Okay. So what happens when an x-intercept duplicates? If you have more than one, it's called multiplicity. And it does different things to the graph. We're going to talk about that in a second. So we're going to talk about multiplicity. So you need to find the x-intercepts. That's going to be your division. Find the y-intercept. How do I do that? X is equal to 0. And then you're just going to calculate it. That's one of the main things you want to do. So you have to graph the x-intercepts. You have to graph the y-intercept. You have to know the end behavior. Okay, smokies. Got that? All right, and then sign analysis between the two zeros. Between the zeros, and that's just a test point. When I talk about sign analysis, that's like that number line, picking a test point to see if it works. Is it positive y values or negative y values? Okay? All right, multiplicity of a zero. What's another word for zero? A zero function. Intercepts. Okay, so multiplicity is when you have your x-intercept more than once. So if you have something like we've had this before, x minus 2 squared plus x plus 2, x minus 3. So we're going to have two x-intercepts at positive 2, one x-intercept at negative 2, and one x-intercept at 3, right? So we're going to have that twice. That's going to happen twice. So when you have a multiplicity of 1, this is a multiplicity of 1 because we only have one of them. That means that it actually, the function will cross the x-axis at that. Okay? So if you only got one of them, it crosses the x-axis like you've always done before. Okay. If it has a multiplicity of 2, in this case, that's this one here, it creates a balance. So it hits at 2 and it doesn't cross it, it bounces back up. So if you have that x-intercept twice, it creates a bounce. If it has a multiplicity of 3, you end up getting this drag, and you have to show that there is a drag. So this graph is this. So where's my x-intercept? 0. If we just had one of those, that would be a linear function that just crosses, right? That would be y equals x. But because we actually have 3 of these, we have 3 x equals 0s, it creates a drag. So you end up kind of dragging past 0 and going down like that. You don't just do a straight cross. This multiplicity of 1 directly crosses it. multiplicity of 3, you do cross it, but you're dragging through that x-intercept, and you need to show that in your graph. So when I was doing my practice polynomial project for you guys, I needed one balance in my graph. And had to cross I've got an exponent of 4 for mine, and I needed one balance, and I needed to cross in 2 other places. Right? Does that make sense, everybody? So when you're looking at a graph, when I look at this one, I need 1, 2, 3 x-intercepts. I know it's an odd function, right? Because it's up in 1, down in 2. So what's the coefficient on this? So this is positive or negative? If it's up in 1 and down in 3. Positive. So we know the leading coefficient is positive on this one. We know that we need 3 x-intercepts because it's crossing. Here, when I look at this, I know that this is also a cubic function. Because I have crosses once, so that's 1 x-intercept. And because there's a bounce here, that means that x-intercept occurs twice. And it's up in 1, down in 3. Does that make sense to everybody? And then this one is also a cubic function. It has the exact same intercept 3 times, and it creates a drag. Okay, so cross, bounce, or drag. That's what you're going to be dealing with. Got it? We're not going to go forward the same. We're only going to go cross, bounce, drag. Okay, so for these two graphs on your page, you have 2 graphs on the page, right? Perfect. We got to state the degree. We have to assign the leading coefficient. We need to do the x-intercepts and the factors of the function. And the intervals where the function is positive and where the function is negative. Right. Easy peasy, right? So let's do the easy stuff first. Cubic. So what kind of degree? Cubic. Degree of 3. Okay, what am I doing next? Okay, leading coefficient is positive because it's up in 1, down in 3. Okay, what's the domain and range for this graph? Domain is negative infinity to positive infinity. Range is saying negative infinity to positive infinity. You might say, oh, but it only goes up to like 3.7 here, or down to negative 19. But these arms continue on forever. So even though it has a max min, in calculus we call this relative maxes. Because in this area, that is the max point. This is a relative min, but the absolute max is infinity. Make sense? There's one. Perfect. Okay. So next up on my list, x-intercepts. All right. So my x-intercepts are at -4, -2, and +2. Now I want to write those as factors. What would those be? Now we'll write them as factors. So put them back in the brackets. X plus 4, x plus 2, x minus 2. Okay, so you're going to be able to work backwards, forwards. And then let's talk about positive, negative intervals. So what this we're looking at is what is happening with the y values. So what's happening, from here to this x-intercept? What are my y values doing? Are they positive or negative on this section of the graph? They're negative. So from negative infinity to -4, that is a negative interval. Does that make sense to everybody? Because my y values are negative. Okay, next, between -4 and -2. Positive. Between -2 and +2. It's a negative interval. So when we're talking about intervals, whether they're positive or negative, we're solely looking at, we're making a statement in the domain, but we're saying on this part of the domain, all the y's are negative. Okay? So it's a domain statement here, but this is talking about what the y values are doing. And then my last one's going to be from +2 to positive infinity. Okay, you guys do the next one. I'll catch up to you. Thanks, sir. Of course. I'll just go back to this page so the people on the video can see this page. Good job, people on the video. All right. So, a couple of things. Let's plot our x-intercepts really quickly. +1, -2, -3. I should probably put some increments on here, which I'm really bad for forgetting. But you know who else is really bad? All of you. All of you. Collectively, as a sweeping statement, all of us are getting really bad at it. We need to get really better at it. Okay, so that's a beautiful graph. Next step, I'm going to put my y-intercept on. It is negative. So maybe I should probably change my interest on my y. Okay, polynomial function. What is it? David, you do the multiplying. What is that? Did you multiply these factors all together? Yeah, what did you get for the degree? Okay. So it's got a degree of 3. And David, what was your leading coefficient? Oliver knows it's positive or negative. Positive, it's +1, right? So again, if you don't want to spend time multiplying the whole thing out, you don't really need the whole thing, you just need kind of parts of it. X times x times x is going to give me an x cubed. I know that the leading coefficient on that will be 1. Does that make sense to everybody? So I'm only doing parts of this because I don't want to waste time multiplying the whole thing out. So it's got a degree of 3 and a positive leading coefficient. So what do we know? Up in 1, down in 3. Okay. Now here's the sign analysis part of it. Positive x times positive x times positive x. So David's first term was x cubed, just a plain old x cubed, right? Unless you're really wrong. I don't think he did either. I think he's on the right track. Okay, so let's talk about sign analysis. We're big fans of this in the math department. It's one of our big. One of our favorite things to do. I treat it like a number line. So I'm going to have -3, -2, and a +1. Over here, I'm going to put my factors. I think you could do a lot of this in your head, but I'm going to show you all the steps because I don't want to. I don't want to skip any, so everybody's got a full and complete table. Okay, so you have 4 sections of this table because 4 sections. So we need a value less than -3. Okay, what's the value less than -3? -4, thanks. So that's the value I'm going to substitute in everywhere I see x. So if I put -4 in here, what's the value of this factor? It's going to be a negative. I don't really care about the number. If I put a -4 in here, what's the value of this factor? Also negative. If I put a -4 in here, negative. So if I take a negative, multiplied by a negative, multiplied by another negative, what's my function? Negative. This is the one I care about. This column here is the most important. That's the one I care about. So what this is telling me is my y values, when x is less than 3, my y values are going to be negative. Got it? You could probably do this without breaking this down. You could probably do it looking at this. I have faith that you could probably do that. So what's the value between -2 and -3? -2.5. So if I put -2.5 in here, if I put -2.5 in here, still negative. If I put -2.5 in here, positive. So what's my function going to be? Positive. Okay, -2 and 1. 0, thank you. So if I put 0 in here, this will be negative. This will be positive. That'll be positive, which means it's negative here. Value greater than 1. You're just going to use your 1.5. It's going to work. If I put 2 in here, positive, positive, positive. My function's positive. Yeah? You can. And like I said, this isn't necessary, but this will confirm your plan. And it might get a little complicated based on your balances. Like you might not catch it if you don't do the multiple x intercepts. Because if we had something here that was negative, and you forgot to write that this was 2, it would remind you that there was a balance. It's just a safety net. You don't have to do it if it doesn't work for you. But it's kind of a safety net to make sure that you can do it. Exactly. Why would we? Okay, so let's connect the dots. So we know we're up in 1 and down in 3. So we know this section of the graph is going to be positive, which makes sense. Don't forget, you must cross through that y-intercept. And so we know from 1 to -2, our values should be negative. So this is good, this is good. And we know that these ones should be positive, and we know that this one should be negative. Oh, you know what? That graph's coming, that graph. What? 0 mark? Because I do this all the time and I'm really bad for it. There we go. That's a prettier graph. What? Hey. Could be a myth, but might not be. You just connected dots. Okay, fair enough. No, I won't deduct you mark. Yay. It may be, but you don't have the skills to figure out what the rows minutes. Kevin does, so he can judge that part. Kevin has to do it now. Okay, so here's the thing, is that we don't know that the y-intercept, it seems like a place that we would make it, right? Like it seems like a natural place. But what I want you to understand is it might not be the minimum of the graph. So I'm trying to remind myself that it's not always the min. So I like to just remind myself not to make it the min. It's just something I do because I have to honor that there's probably a relative. It's very rare that your y-intercept is your pivot. Just saying. But you guys don't know how to find it yet, so I can't touch your marks for that. What else am I missing from this graph? I'm going to text you a half mark. It's labeled one. You have to label flights. So, and we're getting terrible at it. We're bad at labeling our increments, and we're probably even worse at doing our coordinate pairs. And I've been sloppy about deducting numerics, because I'll go with that, because, well, I can only fall to. And I mean, don't forget your pattern. You got the there for the rotary and okay. Next one. Whew. What's the degree of this one? 4. What's the leading coefficient? Negative. What's the y-intercept? Okay, so how did you do that? Yeah, there's notes from last year. That's kind of a pain in the ass. Are you almost done? Okay. So it still works. Don't work too hard at like actually multiplying this out. You guys don't have that time in your world to do that sort of stuff. So do the quicker, faster version of it. Phil, do you have a question, or do you just? What's your question, Phil? Okay, x-intercepts. X-intercepts are going to happen where? -3, +4. So I can go -5 here, +5 here. Feel like maybe this should be 10, 20, 30, 40, 50, 60, 70. That's not going to work. 20, 40, 20, 40, 60, 80, 100. That's supposed to be 120. Let's start. There's going to be a fight on the playground in our school for sure. If she wasn't in Paris right now, she would have to deal with me. I told her she's in Paris. She's not coming back. Okay, so x-intercepts go on. -3. Y-intercept somewhere slightly up here. But there's something about this one that's important. It's got a drag. So that one's a drag, and that's just a straight cross. Okay, so if I were to do my sign analysis, I'm going to pick a point that is less than -3. I'm going to pick -5. You're getting voted off the sign. If I put -5 in here and then cube it, I'm going to get a negative number. A negative number times by a negative is going to give me a positive, and then I'm going to have another negative number in here, so positive times by a negative. I anticipate that this section of the graph should be below the x-axis. Okay, I'm going to pick a value. Well, this is nice and easy. In between -3 and negative, whatever, positive, whatever that one is, 4. Pick 0, we already calculated that. What's that? Positive 1 away. We already did that when it was 0. So you anticipate that between the two x-intercepts, you're going to have values above the x-axis. And then if we pick a value that's more than 4, so we're going to put 5 back in here. Positive, negative, positive. So it'll be negative graph. I don't always need to write all the stuff down, but it's just a way to catch yourself, just to make sure the graph is doing what you think it's going to do. So even function, leading coefficient, that's negative. Down in 3, down in 4. So this is a straight cross. Ooh, let's do something exciting here. Ooh. Connect the dots on that one. What? You know, maybe. Did I need this little balance in here, this little thing going on here? No. I didn't. Try to give it a little bit of character, give it a little bit of pizzazz. Again, we don't really know max and mins, we don't know anything like that. We don't have the ability to solve for it yet. So your graph may look different than mine, but I'm looking for the key features. I'm looking for the leading coefficients. I'm looking for the drag. This has to be significant through here. It's not a very big drag. I think I could do better. Let me do better for you guys. It's not a very good drag. I got it. That's a better drag, although you can't look this up. So you want to have that significant drag. It's got to be exaggerated so you can tell it's a drag. Okay. 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 So this one kind of sucks because what? It's not in factor form, so we need to make it. Exactly, we need to make it a factor form, but let's quote some information about this. It's got a degree of 3, and it's got a leading coefficient that's negative. So you're going to have up into down to 4. No, crazy fun. Okay, so now we are going to factor. Can almost get voted off down. Carson will keep you. Okay, so how do we do this? This is 3.3. How do we do this? You just go. You got to take the factors of -4, and you're going to substitute them into this to see if you get a remainder of 0, and you know that's a factor. You're going to do 2. So if I put 2 in here, that'd be 8. That'd be -16. Putting -2 in here, I'm going to get -8, +16, -12, -4. He's right. Well, it can be when he's right. Saves us from doing a ton of work. I do all that math in my head. That was hard. So we know that -2, so our factor that works is going to be x plus 2. Ooh, what's our y-intercept? Our y-intercept is going to be -4. So we've pulled out a bunch of important information from it in standard, from the equation in standard form. So it's not that it's for nothing. Yeah, I think it means you're going to be think I can also looking at this and thinking, God, y-intercept from this jump. But I didn't. I did the y-intercept in my head. Sorry. Left from behind, I was skipping steps. Okay, so now I have this. I'm going to do synthetic division. So 2 on the outside. We need all places represented. So that's all the way to the constant as well. That tripped somebody up on the quiz. I don't know who it was. I can't tell you. I can't remember. Yes. Yeah. I'm all the way on the right thing. I just said it and then I didn't do it. Do I have an x squared in here? I don't have an x squared, so it has to be represented by a 0. Okay, so I'm left with negative 2x squared plus 4x minus 2. What am I going to do with that? I'm going to common factor to negative 2 because that's just ugly. I mean, you could still do complex trinomial factor. But why? Because you're going to end up, you're going to end up somewhere that's, well, it's not that it's not nice. It's just you're going to end up having the common factor at the end, and a lot of people forget to do it at the end. Okay, so what we know is those are all of our factors for that trinomial. Is it common factor that we're going to? Okay. It's not going to help us for x-intercepts. But yeah, we just ignore it for our x-intercepts. So I'm going to go 5, and I'm going to go 5, and I'm going to go 5, and go 5. Getting better. So what do we know what's happening here? What's this? What's going to happen here at positive 1? There's going to be a bounce. And I know my leading coefficient is negative, and I know it's a cubic function. So what do I have? Up in 2, down in 4. Oh, what else do I need? Y-intercept. So if you did this, and you did it like this, it is wrong. It's completely wrong, but I've seen people make that mistake before because they forgot their bounds. They totally ignored the end behavior and said, well, I have 2 x-intercepts, therefore I must have a parabola, which is sad because that means we didn't do a very good job teaching you. But there's going to be a bounce here, and we said it would go up in 2, down in 4, which it does because of the bounce. I'm having a hard time. Yep. You don't have to. You don't have to. I'm going to deduct some marks for that. But like I said, I was practicing currently, and it kind of fell off the bus. Oh, goodness gracious. Oh my goodness. It is a lot. How do you feel? Are you guys feeling okay? You've already learned everything? The next one's transformation form. The whole grade 12 career is about transformation. Okay. So David, I'm going to do a table of values. Yes. So I'm doing a table of values for this. So, -2, If I put in -2, what's going to be my y value? -8. It's a cubic function, you can have negatives. If I put in -1, what's my answer? -1. If I put in 0, 0. If I put in 1, +1. If I put in +2, what do I get? Positive 8. That's kind of important because when we do transformations, it's going to help us. So looking at this, we have an A value of -2. So let's talk about what that means. What's the negative tell us? Yes. So the negative tells us we have a reflection in the x-axis. We have a vertical stretch. I hope you guys are listening because this isn't writing very well. By a factor of 2. We have a horizontal stretch by a factor of 1/4. We have a horizontal shift where 1 unit right, and we have a vertical shift. Hurry up. Okay, so we do stretches first and then we do shifts, right? So to our right, if I were to do a mapping rule, start off with my x and y's, what mathematically do I do to my x's? Times it by 1/4 and then add 1. So 1/4 x plus 1. And then for my y's, I'm going to times those by -2 and add 3. I find the mapping rule helpful because it shows me exactly what math I have to do. So if I were to do my new table of values for that function, if I were to do my new table of values for that function, x is -2 times by 1/4. We'll cut it out. -1/2. And then I'm going to add 1, which gives me +1/2. Okay, -1 times by 1/4 gives me -1/4 plus 1 gives me 3/4. 0 times 1/4 gives me 0 plus 1 is 1. 1 times by 1/4 plus 1 is going to give me 1 and 1/4. 2 is going to be 2.5. Okay, so now looking at the y's. -8 times by a -2. +16 plus 3. +16 plus 3, 19. So now I have -1 times by a -2 is a +2, plus 3 is 5. It's going to be 3. This one's going to be 1. -16 is -13. Ouch. We don't know where x-intercepts are. None of this told us anything about x-intercepts. But what you have is you have coordinate pairs that you can graph. Okay? It's going to be ugly. What do you know about this graph? It's going to have how many x-intercepts? How many will this graph have? still a cubic function. It's still a cubic function. All you're doing is taking that cubic function and doing this to it, doing this to it, and moving it somewhere on the graph. You're not changing how many x-intercepts you have. Okay, so I guess we can graph this thing. Let's do 5. Let's not invest too much time in this. We'll only graph parts of it. So at 1, we were at 3, that's okay. What would this point match on this graph? This is my x-intercept. A basic cubic function is going to have a drag across the 0. Oh, that's a nice drag. That's a good drag. So that's going to be across the 0. So that drag just got translated to there. So you're going to have a drag in the graph at that point. Okay. I love it. I love when we're all on the same page. 3/4. One 1/4 is going to be at 1. And the graph. So I'm going to end up with a graph that has a drag. It's an odd place to have a drag, but it's a transformation of your original graph. So you need to know where the original drag is in order to translate it. And yes, I would expect to see the significant drag. Do I need to label points on this one? How come? I got a data table of values. Ooh. Well, traumatizing. We got 9 minutes. Can we do the last page first? Nobody likes these. They're not hard. An integer. Everybody needs an integer in their life. Okay. So what does consecutive mean? Nope. That's congruent. Yeah. Carson, give me an example of 3 consecutive numbers. Oh, you're brilliant. Thanks. Sometimes you will see 3 consecutive odd numbers. You'll hear that statement. So that would be 3, 5, 7. Okay? So pay attention to what it's talking about consecutive. What are integers? So they're both positive and negative. This is really important because in these questions, it will say things like natural numbers. So that would mean you reject a negative answer. So, okay, so be forewarned that in these questions, the language makes a huge difference in what your answer looks like. So if it's a natural numbers and I get a negative for an answer or plus minus, I reject the negative. Okay? But this is telling me it's integers and they have a product of negative 2, 10. Okay, I don't know the integers are 1, 2, 3. But I do know that my first number is x. So how would I represent my next number in that consecutive sequence, Carson? I know. How do I represent my third number? X equals 2. And please notice that I'm multiplying them all because it said their product is equal to negative 2. Yeah. Okay. So I don't know. Well, my first number is I'm going to call it x. So how did I get from 1 to 2? Mathematically speaking. I added 1. How did I get from 1 to 3? I added 2. Okay? And if they were odd numbers, 3 to 5, what do we do? my first number is 3, my second number is 5. How do I mathematically get the second number? Plus 2. So it'd be x plus 2, x plus 4 for consecutive odd even numbers. Keep that in mind. This question show up. Okay, so now we're going to deal with it. P, David, multiply. No? No. Okay. Did you just call him a gender? Not very gingery. Okay. That's exciting. So what are the 3 integers? So this answers part A. That answers part A. To get to part B, what are the integers? How am I going to solve this? I'm going to factor it. So I'm going to have to figure out what the factors of positive 210 are. 210 and 1. Okay, I was like, 1 don't work. 5 work. Well, what kind of 5? 7 works, 5 works. Negative 7 works. Positive 5 works. No, negative 5 works. So we know that, well, Kevin knows from his notes that it's negative 7. I know from my notes that it's negative 5 or negative 6. But you got to try. Because you're not going to have last year's notes when you test or yeah. Maybe you will. Me too. So we'll take negative 7 just for funsies. So I'm going to put negative 7 in there. So I'm looking for my remainder when I'm doing negative 7. Hey Kevin, I don't have a calculator. You're going to have to help me with last year's notes. The last semester's notes. What's negative 7 cubed? Thanks. 3 times 49. 147. Oh, that's a 7, by the way. I got 14 plus 210. And you're telling me this all equals 0, right? Oh, yeah. Not my day. Okay, so I know that negative 7 works. So what's my factor? I am not having much fun. I have to, before I go to synthetic division, I have to write it like this, because I will screw it up. I won't, doing it your way, you don't have to do this, right? But, so from this, I'm going to go 7 on the outside. 7 on the outside, and then I'm going to have 1. Are they all represented? 3, 2, and 210. So 1, 7. That's supposed to be a negative 4. That's going to be a negative 28. That's going to be a positive 30. That's going to be 210. That's going to be a 0. So I'm going to have x squared minus 4x. Okay, slow down. It's telling me I got to slow down. Plus 30. I'm going to ruin something for you. So the factors of 30 that add up to negative 4, you're not going to find any. So if you don't find any, you need to go to the quadratic formula next. Okay, I'm going to ruin this for you. The quadratic formula doesn't work. It's unfactorable. So this is perfect. This is easy. If it's unfactorable, this is easy. Because I have this as a factor, and I have that as a factor. So what are my numbers? I can solve this one. So x is equal to -7. What's my next consecutive number? What's my next consecutive number? If you went -8, -9, -10, it would be wrong. Because your statement said x plus 1, x plus 2. We're adding to a negative number. So these would be my answers. Yes?
What's the